Okay, hello, discrete math class. This is a short video explaining digital learning day number 2. You're going to be working on the river and well problem. This problem here, it's sitting as a downloadable PDF, or you can read it here on this page. This is the directions, what's going on, and this is where you're going to do your work. You're going to be drawing lines and points, 1, 2, 3, 4, 5, 6 points on this graph, and you're going to be calculating distances. For example, if I put a green dot there, let's make it green, Joe. If I put a green dot there, I need to know how far this is to the river. 1, 2, 3, 4, 5, 6, 7 miles. And I need to know how far this is to the well. And that's what we're going to work at right now. If the point is directly north, south, east, or west of the well, then the distance is easy. You can simply count boxes. So if this is our well, and we have a point directly north of it up here, this is 1, 2, 3, 4, 5, 6, 7 miles. 7 miles. If the point is not directly north, south, east, or west of the well, you have to use the Pythagorean theorem to calculate the distance. So this short explanation is how to do that. Let's suppose our point is here. You count the number of boxes north. So let's see, 1, 2, 3, 4, 5, 6, 7 miles north, and the number of boxes east or west, 1, 2, 3, 4, 5. Okay, and what we now need is the length of this hypotenuse of a right triangle with sides 7 and 5. Okay, so this is how you do it. The length, let's call this point P and this point F, as in the directions PF, the distance from P to F, which is the focus of our conic section, will be defined as the square root. You're going to have to square the 7. Square root of 7 squared, and then you're going to have to square the 5. So 7 squared plus 5 squared, we can clean that up a little bit. That's the square root of 49 plus 25. 7 times 7 is 49, and 5 times 5 is 25. And we can clean that up a little bit, which is the square root of 74. Now, how much is the square root of 74? What I want you to do is not to use a calculator. So the calculator will tell us if we had a square root button, or even if we even had a calculator, you could get the square root of 4 is about 8.6. That's not what I want you to do. In fact, this assignment is assuming you do not have a calculator. So if you go and look at this 20 times 20 times table, there's a task on the bottom. Again, this is a downloadable document on your class page, so you should probably look at that. And there's 5 tasks on the bottom that you'll have to do. And I'm going to step you through that right now. These are the first 5 questions that you're going to have to do on your digital learning day assignment. The first task is to locate the perfect squares. So where are the perfect squares? Well, 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so forth. Okay, so there's 20 perfect squares all in a row. You need to describe how you would find those perfect squares. That's number 1. Number 2, is 361 a perfect square? So as you look down this main diagonal, and we keep going down, and we're looking for 361, there it is. So is 361 a perfect square? You'll have to answer yes or no. And then is 271 a perfect square? So we're looking for 271. As you go along the diagonal, I see 256. Let me use green here. So I see 256. And I see 288, okay, 288 and 256. Sorry, 289 and 256. So there's 289, there's 256. Again, not very clear on this video, but if you have the downloaded PDF, it's pretty clear what's going on here. And 271 is not in there. Okay, so you'll have to answer yes or no for is 271 a perfect square. Okay, third thing, square roots of perfect squares are easily found. You have to look at your table and find the square root of 256 and also the square root of 324. So that's easy, just read it off the table. The next thing you need to be able to do is to estimate, or first of all, explain why the square root of 120 is not a perfect square. Not in that row, how you described that row was part of number one, not a perfect square, but it's in between 11 and 12. So the square root of 128 is some number between 11 and 12. And we can tell that by looking at the table. So in the table, I see 121 right here. And I see 144 right there. 121, 144. Those are perfect squares. But 128, which is what we're looking at, is not a perfect square. 128 doesn't fall in there, but it does fall between 11 and 12. So our estimate for the square root of 128, square root of 128 is about 11 and a half because it's some number between 11 and 12. Another way of looking at it is the square root of 121 is 11 and the square root of 144 is 12. You can get that from the table. So the square root of 122 is going to be about 11 and a half. And that's what I want you to answer. I do not want you to take your calculator and go, what's the square root of 128? Because the calculator will do that for you. Square root of 128. It's about 11.3. Well, I just want 11 and a half. That's all. Okay? So then go ahead and estimate the square root of 300. That's part 5 of your editable Google Doc. The square root of 300 is about what? Okay, now let's go back to the river and well problem. River and well problem, we're looking at this idea, and now we have to estimate the square root of 174. All I want to do is guesstimate how much it is. Go to your times tables, look at that main diagonal, and you'll note the square root of 64 is exactly 8, and the square root of 81 is exactly 9. So the square root of 74, which was our problem here, is about 8.5. 8.5. So for the river and well problem, this point is 7 miles away from the well. It's, let's see, how far away from the river? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11 miles away from the river. Remember, the river is the straight line. And how far from the well? Well, let's see. It is now going to be about, we estimated it, about 8.5 miles. So 8.5 miles. This point P, 8.5 miles away from the well, 11 miles away from the river. Okay. Now, I would like you to spend some time working on this river and well problem. The directions are off here to the right, right? Problem 4, right? You're supposed to have a hard copy. I'm not going to ask you to send that in digitally. You're going to bring it into class on Thursday. A hard copy with a black line through it. And then there's going to be a red line, right, where PD is half of PD, or PF is half of PD. And then there's going to be a green line. You can use blue, I suppose, where PF is 2 PD. Okay, so work on that. What I want you to do for your digital learning day assignment is I'm going to give you 10 problems, And each problem will consist of 2 ordered pairs. So 3, 5, and I don't know, I'll make one up here, 2 and -6, okay? And these are going to be called A and B. And your task, you can use graph paper if you like, but you don't have to. Your task is to find out how long AB is exactly. That's going to be using a square root, and then approximately using the table. Okay, so this is not problem 1, but I'll show you how it would work if this were problem 1. You could draw a little picture if you like. So many students like pictures. You can do this without a picture. A is 1, 2, 3, 1, 2, 3, 4, 5. Okay, so this is A. And B is 1, 2, and then -6. 1, 2, 3, 4, 5, 6. So down here at -6, and that's B. Okay? And our task is to figure out exactly how long it is, and then approximately how long that is. Okay? And so this is how you do it. You pretend this was a river and well problem. Figure out how far north, south you'd have to go, and the vertical change here. Well, this is down here at -6. This is up here at 5. If you count boxes, that length, that vertical length would be 11. It's 5 above the axis and 6 below. So that's 11. And then the distance east-west is this much. Well, this had an x-coordinate of 2. This has an x-coordinate of 3. So it's only 1 mile going that way. So the exact value would be 11 squared plus 1 squared. And you'll have to square those numbers and add them up. So that's the square root of 121 plus 1. So the exact answer is the square root of 122. Now, go to the table. You'll see that the square root of 121 is exactly 11. The square root of 144 is exactly 12. So the square root of 122, we're going to say, is some number between 11 and 12. Now, we're going to say 11.5. Now, frankly, that's way too big. You would suspect that the square root of 122 is really close to the square root of 121. So maybe 11.1 would be better. And, you know, if you wanted an even more guesstimate, more accurate guesstimate, you could put it into a calculator. Don't have to do that. So the square root of 122. Okay, so 11.04, really close to 11. I'm happy with 11.5, and that's what I want. Okay, so 11.5. Okay, so that's that. I'm going to stop this video here. Go to the Google Doc, work the 10 problems. I give you point A, point B. Oh, I said you could do this without a picture. Let me explain how to do that real quickly. The distance formula, the distance by definition is you subtract the x-coordinates, x1 minus x2, and then you square that difference. And then you subtract the y-coordinates, y1 minus y2, and then square that difference. So for this particular problem, the 2 x-coordinates are 3 and 2. We're going to subtract those and square it. That gave us our 1. And then we're going to take the y-coordinates, 5 minus, now it does say minus here, but the second y-coordinate is minus 6. So you should know that 5 minus a minus 6 is the same as 5 plus 6, which is 11, and you square that with 121. Okay? So yes, you can do this without a picture, just using the distance formula. Okay, you get all 10 of them right, that's an A plus. 1 wrong is A minus, 2 wrong is a B minus, 3 wrong is a C minus, 4 wrong is a D minus, 5 wrong or more, or if you don't submit it, is recorded as an F. Okie dokie, let me stop this. Happy digital learning.